Okay? So far so good? All right, feedback system. So what I just showed you right here is, this is what we would call a negative feedback system. Because what happens when I have a deviation from the set point, what happens, something is going to be occur that is going to negate the stress. And when you have something that negates the stress, I would call that a what feedback system? Negative feedback system. Okay, and so we've got some good examples of this. And one good example is tyrosine and metabolic rate. Let me just see what I've got here. So what I want you guys to do is pull out your endocrine pathways handout. This is a big one. Okay, see what?
I'm excited.
That's nice. Okay, and page 4, I have the example of this. And listen, about your exam, oftentimes what I do is I have people just illustrate a lot of these illustrations. I'm not going to have you do that. You guys are going to be doing the female reproductive illustration and guided essay. But I'm not going to have you draw all these, but you want to. You're going to see the lecture I'm going to be giving you in great part is represented by these images. So this is going to be an important study tool for you. Alrighty? And so right here on page 4, you have an example of a negative feedback system. And what happens is this. What I'm looking at here is the metabolic rate. And you guys know when you sleep, and we've sort of talked about this before, but when you sleep, does your metabolism just stop? No. But it does go a little bit slower. And so what we note is that our metabolism is affected by a very important hormone. This is like putting your foot to the pedal to the metal, but this is tyrosine and triiodothyronine. You can sort of see them right there. And so the way this negative feedback system works is this. Okay, I'm going to put 2 graphs up here. Okay, and so right here I've got my, let's say this is my basal metabolic rate. And then right here, I'm going to have my relative concentrations of these hormones, T3 and T4, which stands for thyroxine and triiodothyronine. And what I note is that the hormone concentrations go up, then what happens is the basal metabolic rate goes up. Do you guys see? When the hormone concentration in the bloodstream goes down, the basal metabolic rate goes down. When the hormones go below the set point, what I note is my basal metabolic rate goes below the what point? And I'm starting to feel a little bit lethargic, like I need a cup of coffee or something or whatever. And then what's going to happen, the negative feedback system needs to negate the stress. And so what it's going to do is going to start secreting these hormones into the bloodstream, bringing it back up to the what point, everybody? Sure, so the set point. So what happens, this is sort of an interesting negative feedback system, because the goal here is monitoring the basal metabolic, is adjusting the basal metabolic rate. But what the control center does is it doesn't measure the basal metabolic rate, it simply measures the concentration of these hormones, because the hormones are a reflection of what the basal metabolic rate works. So what happens here, again, so at the bottom right-hand of page 4, you can see there's the increase in the basal metabolic rate as thyroxine and triiodothyronine goes up. But as it goes up, what's going to happen? It's going to have an effect on the hypothalamus. Your hypothalamus is controlling the basal metabolic rate. So far, so good? Okay. And so what happens is this, is in your hypothalamus, we're going to have this hypothalamic hypophyseal portal system. Okay. And so what will happen is that if these concentrations go up, that's going to have a negative effect on the system, on this negative feedback system. So what the hypothalamus begins to do is it now begins to secrete less thyrotropin releasing hormone. So let's just go over this. But when you see the word tropin, when you see the word tropin, what tropin means is that it affects another endocrine gland. A tropic hormone affects another endocrine gland. A tropic hormone affects another endocrine gland. Now, this particular hormone, TRH here, what it's going to do is it's going to affect your thyroid gland. So I'm going to call this thyrotropin releasing hormone. So thyrotropin releasing hormone is going to go in through the fenestrations into my hypothalamic hypophyseal portal system. It now comes in contact with the anterior pituitary gland. Are you with me? And once it comes in contact with the anterior pituitary gland, now it's going to secrete another hormone called thyroid stimulating hormone. What do you think thyroid stimulating hormone is going to do? Stimulate the thyroid gland. And so now that goes through the fenestration. So thyroid stimulating hormone is now into the bloodstream. Now it comes in contact with the thyroid gland. The thyroid gland now responds by secreting thyroxine and triiodothyronine. The result is the concentrations of these hormones goes up, okay? And then the result is my basal metabolic rate goes up, okay? And so there's an illustration of that, and so that's the way it is. So when the concentrations go up, it'll have a negative effect. When the concentrations go down, it will allow the system to work, okay? The other one is a positive feedback system, and I guess it's worth mentioning that right now. But when I have a negative feedback system, what happens when I have a deviation from the set point, something happens to bring the system back to the set point. But in a positive feedback system, it's a little bit different. What happens, I've got this this measurement, which we're just simply going to call stasis. We're going to call it what, everybody? Stasis. And what happens is that if I have a deviation from stasis, what will happen, that deviation from stasis will be picked up by some receptor, will convey it to a particular control center. It's going to then communicate to a particular effector, and the effect will be to enhance the deviation. Do you guys see? Alrighty, and so the result is going to be an enhanced deviation. And then the result is now the receptor picks that up, conveys it via an afferent pathway to the control center. The control center sees that, gee, we're way off, and we have an enhanced deviation, and now it sends some more hormone to a particular effector. The effect is to further enhance the deviation. Do you guys see? So a positive feedback system is a build-up system. And as it goes, it builds, until all of a sudden something pops. And what happens is that I'm going to reach a particular threshold. Yep, threshold. And once it hits that threshold, some physiological event occurs. And then I go right back down to stasis. To stasis. No partial credit for that one. To what, everybody? To stasis. No more Mr. Nice Guy. Okay? And of course the illustration, we did this in A&P 1. Do you guys remember this?
I do remember this.
Maureen, if you could hit the lights. Oops. Thank you. Is that clock right?
Yeah.
That's it. I gotta check you guys. I learned from the last couple times. You guys left early. Yeah, a few times. I was looking at the clock up in the lab. It's not right. You
It's a
said,
half hour fast.
yeah, and you guys left early.
What day was this?
I don't know, too many.
Oh, I mean,
I think it was like twice.
I wasn't here.
Nobody said a word. No one said anything. At any rate, so childbirth is a good example of this. You were early?
I really was, and I left class, went straight to work like I used to.
I know like half an hour every day.
All right, well, you owe me. All right, at any rate, what happens is, you know, the uterus, of course, is going to be filled up with baby, and there's going to become a certain point where baby needs to be kicked out, right? And so we talked a little bit about that. And there's going to come a point where that child gets so big that there is going to be a system now that is going to cause that myometrium to begin to contract. And the control center, of course, here is going to be my what I miss? Hypothalamus. Now, in this particular case, when I did with T3 and T4, that was the anterior pituitary gland. That was the what, everybody? The anterior pituitary gland always uses that hypothalamic hypophyseal portal system, period. Okay? But right here, I'm dealing with the posterior pituitary gland. And we dealt with this a little bit, particularly when we're with the urinary system. But what I'm going to have here are some special cells here, which I'm going to call, does anybody remember, because it was on your exam? Good, neurosecretory cells. Neurosecretory.
What exam was that?
I don't know.
AP1?
No, your last exam.
Oh,
No, last exam. Not Friday.
You got it wrong, don't worry about it.
I got it wrong.
last exam.
No, on that.
And so what's going to happen is the neurosecretory cells, guys, they are sort of like neurons, okay? And so they will depolarize, and then they can send an impulse and conduct an impulse. Now, you guys know when you deal with the nervous system, you'll eventually get to a synaptic end bulb. Do you guys remember that? And then what will happen is you will exocytose, you know, acetylcholine or some sort of other neurotransmitter into a synaptic cleft. You guys remember? All right? But in this case, when I'm dealing with a neurosecretory cell, everything is the same, except when the synaptic end bulb exocytoses that chemical messenger, it doesn't go into a synaptic cleft, it goes into the bloodstream. Note, that's not the hypothalamic hypophyseal portal system. And so it'll immediately go through the fenestrations, and now it's in the bloodstream. And in this particular case, the hormone is oxytocin. And so in the urinary system is ADH, okay? And that was those are actually the only two hormones that use that system, is oxytocin and ADH. And they'll use the neurosecretory cells. And so the result is oxytocin comes in contact with the uterus, and the uterus now begins to what, everybody? Contract. And then my stretch receptors stretch even more. And now my neurosecretory cells from the hypothalamus secretes even more oxytocin. And now there's more contractions. And you can see it's building, 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 building. And of course you're dilating at this point until all of a sudden you hit a little what hole? Threshold, and pop, the baby pops out.
Still not how it happens, but okay.
Say what?
That's not how it happens.
So I thought ADH was secreted from the anterior pituitary gland.
Posterior.
ADH? Anti-diuretic hormone?
Yeah.
Really? I thought it was anterior.
No. Guys, let's start with positive feedback system. Okay, so that's a good example. That's a review from AMP1, so that's convenient. Okay, so next. Mechanisms of hormonal control.